Well, hello. Welcome to Turning Infrastructure into Software through Cloud Engineering. My name is Matty Stratton, and I will be with you for the next little bit on a journey of some magical infrastructure discussions. Real quick background. As I said, my name is Matty Stratton. I am a staff developer advocate at Pulumi, which happens to be one of the things we're going to be talking about. I'm the global co-chair of DevOps Days. I started DevOps Days Chicago. If you're into podcasts and DevOps and things like that, you might want to check out Arrested DevOps, which is my podcast. And yes, my license plate does say kubectl, which means I am authoritative on how to pronounce it, which is kubectl. But enough about me, as hard as that is to say. I want to kind of think a little bit about how we got where we are, especially when we think about things like how we provision and think about our infrastructure. And I think there are kind of like three main waves if we kind of look at this cloud transition that got us where we are. So if we think about in this first wave, this was when we were starting to kind of might have this sort of three-tier, N-tier app situation, right? Where you'd have your app, maybe you've got data layer behind that. And this was when we were living in that world where all these things were maybe running on virtual machines. I'm not going to go back so far as before when everything was metal. But we're thinking about, mostly private cloud for lack of a term, if we want to keep that consistency. We're sitting there, we're running a lot of VMs inside of our virtualization hosts. And this was kind of the way the world looked right there. And then we were kind of in this transitional wave. And this is where we were, we still had our maybe scenarios. We had some VMs sitting there running MySQL in this place where this happened, but it was partially dynamic, right? And we got a little bit less monolithic. We started to have kind of maybe a mix between, we had some stuff still running in our VMs, but we were starting to dabble into containers. We're starting to put some little bits of our system. And this is where we started to get into that oh so wonderful hybrid world where we're still running maybe our VMs in our data center, but maybe starting to access some of those containers maybe we're in the cloud or vice versa. And then if we look at our modern setup, and this is where everything's very dynamic, and we have these hyper-connected services, right? Our systems are incredibly complex today, and we see them as contracts between the services as well as much as opposed to a large monolith, right? And this is where we're bringing in things like running with containers, and Kubernetes is coming into here, and we're doing serverless. And at this point, it's mostly happening in the public cloud. Of course, there are exceptions. I'm making generalizations, but we think about as an industry, kind of these waves that we've moved through, where we kind of see, again, there's all these different pieces across multiple different vendors. Some are services that are ours and some are others. And how do we tie this all together? That's where we've gotten. And the reason I kind of come to this is it has to do with how we think about how we provision and configure and reason about that infrastructure. And that's, again, if we kind of think through those evolutions and a little bit of waves. So the starting point for almost anybody, and when we think about these cloud resources and places, is how are we, we're using some type of a web console, and this can be something through the console through your cloud provider. This is even back if we're thinking about with your virtualization layers, and this is, web consoles like this are pretty dope if you're like, okay, I've got a few services, a few instances, a few things to get going. That there's nothing wrong with click next, right? That kind of we know how to get that stuff done. But this kind of became a problem once we started to get to web scale, and scaling the number of resource or the number of people who are doing that, right? So again, I sort of think back, I'd really give you my whole resume, but I spent 2 decades working as a sysadmin, basically, in a lot of classic operations. And yeah, when I was, doing tech ops for, back in, 20 years ago, geez, 20 years ago, shit, yeah. You could kind of just be in there in the VMware console and be like, okay, cool, I got to get a VM. I'm one of 3 people that can do this. I can just kind of go. We just know that doesn't scale. So that's fine. Y'all are here at DigitalOcean Deploy. You don't need me to tell you that. But then we got kind of good. And even in those days, we were thinking about, okay, there were some CLI tools. We'd write scripts. We'd start templating. We'd have golden images. This helps us get our automation better, and we can start to realize some workflows in this place. And we might version our scripts, you'd have, server build v2 .back don't delete, right, .sh. But this was all really kind of bespoke, right? Like we all had our own little automation piece that we did, and then updating them, especially across all of them, and this could be even in things like not necessarily just our bash scripts that did this or our PowerShell or VB scripts, but when you think about things like CloudFormation, all those are the beginnings of that. But then where we want to find ourselves finding this real power is when we are using code, where we're setting up our cloud resources just like we're writing and releasing our software. Now, your organization's differentiator, your core competency, is the service that's being delivered and the architecture of the underlying infrastructure. It's not about being really good at clicking through console UIs or maintaining a bunch of write-only documentation and wikis that tell people screenshots how to do that, or even learning kind of some very bespoke YAML or developing custom orchestration code and testing pipelines. That's all things you can do. But then when you think about things like Pulumi coming in, this is allows us to use familiar programming languages to document and then act as a source of truth for how we want our infrastructure to be deployed. And this gets us into the ability of automated deployment and testing of all of our infrastructure and our related apps that come around that. And I've been kicking around this space for quite some time. I was a user of Puppet. I was part of the Chef community. I worked at Chef for a long time. I was at Red Hat, so I was doing things with Ansible. And so there's reasons that Pulumi resonates to me, and I hope these will make sense to you as we kind of go. And DevOps matters to me a lot too. And we've been transforming what DevOps means, right? And that's, again, as we move from a centralized ops model, we end up with kind of these multi-functional organizations, which is great. But instead of ops being purely a service, ops is an enabler rather than the person who's the blocker. And we have these distributed teams at varying levels of expertise, right? But how can we expose just as much and create the guardrails that we need to have? And this is sort of where we're getting to, right? Like, if I want to find myself in a serverless data center, which is AKA an empty conference room. That's now we got to. I used to go into those giant rooms that were like in the Matrix, where it was like I want guns, lots of guns. That's how I felt going into our data centers, and now our serverless data center is an empty room. So isn't life grand? So I have a lot of thoughts about this idea of infrastructure as code, and I feel like we've been talking about infrastructure as code. We've been using this term for quite some time, but we don't really always use code. And oftentimes we don't even treat our infrastructure as code. We might build our infrastructure using code, but if we can reason about it like it's actually code and use actual code to do it versus the fact that we call something code just because we might check it into a repo somewhere. So when we think about this, these are the things that generally are true about the ideas of infrastructure as code, is we're going to get rid of manual error prone provisioning. Okay, that's cool. That'd be great. And we want to bring software best practices to how we manage our infrastructure. We've been building software for a long time. cats who write software kind of know a couple things. Maybe we can take some of those practices and apply them and reuse them. And if we're running our infrastructure changes through our code processes, like code reviews and pipelines and previews, this sort of gives us a visibility into what's really going on, not just what one kind of place is happening. So, why, right? So again, we want automated and repeatable deployments. We want to improve our time to market. So when we have new applications, we're trying to restore service. We have maintenance to do, something like that. We just want to make these things happen at the velocity that they need to happen for what matters to our business. And we want to have as safe as possible, predictable changes. Nothing's 100% safe, but where we want to kind of see and say, what is this all about? Okay. So when you think about modern infrastructure as code, or what I like to think about as infrastructure as software, the principles around this, some might seem new, some might seem different. But when we think about how we are creating, how we are building with them, we're using programming languages, not a bespoke implementation, which means we have a lot of power. Partially, it's just stuff like we can do conditionals, we can do loops, but we also have to leverage the entire ecosystem around. Let's say I want to write this in JavaScript or in TypeScript. I have the entire TypeScript and JavaScript ecosystem, or Go or Python or .NET. And then because we're creating this, this is a real key thing, is we need to be able to share and reuse abstractions. And abstractions are really, really important to where these pieces come in, because I want to only reason about the part of my infrastructure that I understand and that I have relevance to. So if I can create an abstraction that talks about how my cluster works, but I can expose a couple different configurations around the deployment that matters to the person writing that piece of the code, that empowers them and it lets us continue to run with those good practices that we know as subject matter experts. And when we think about how we're deploying our infrastructure, we need to be able to preview the changes so we understand what's going to happen. We want to make sure that that interface is flexible, depending upon where you're coming from with that, and really needs to be able to integrate into our CI/CD workflows. So if we're looking at, from as I'm doing a deployment of this, I'm going to see right here, like, what are the things that my program is going to do? What is it going to change? And then managing with these are continuing to run, right? We aren't just throwing things over the wall. As an organization, people are using our systems. We have to manage them. We have to understand where they're at and how things change. And are we staying compliant, lowercase or uppercase C compliant with the policies that matter to our organization? So we need to be able to audit all of our changes. We need to be able to understand who did what, and not necessarily, I shouldn't say not necessarily to blame, in fact, not to blame, but to be able to, when there's a question and we're trying to learn, who are the folks that have that proper information. And this allows us to implement policies and controls for us to be able to communicate better. So yeah, we talk about infrastructure as code, but really it's infrastructure as software. And this is bringing software development practices to infrastructure management, okay? And if this sounds a little bit like what we've been talking about in DevOps for the last 11 or 12 years, that's no surprise, because we have, right? Again, we're using abstractions and reuse, and that reuse doesn't mean copy and paste, right? This is that it's a package. It's something that I can bring in as a component. And so the thing about Pulumi, when we talk about this, when we're writing a Pulumi program to build, deploy, and manage our infrastructure, this is really the way that makes sense for how you run your organization, for how your team works, for what you like to do and what you already know. So this is a unified process. So again, depending upon what is your cloud, where is your runtime, what network, what services, what pieces are coming into play, that's great. The programming language that matters to you, which means that opens up the flexibility of all of the IDEs, the tools, the package management for that, and then also again that workflow, that way where this goes to place. And a lot of times on a slide like this, I'll say there's one way, but it's your way. The one way is not the way that you saw in a conference talk somewhere or whatever. It's the way that is appropriate for how your company, how your organization works, and it's approaching to that. So if we sort of think about this journey of infrastructure as code and how we move our way along, and I'm not a big fan of maturity models because that sort of implies an end state, and I got news for you, you're never done. And we're continually seeing as the map gets bigger. But if we sort of think about this journey that we go on as individuals, as organizations, as we really think about how this has changed. So come along with me a little bit, and we'll kind of look at how Pulumi works with this and why this might be interesting and helpful to you. So we think about a declarative syntax, right? And declarative, there's a whole bunch of words. I've been in the config management space for a long time. We love to talk about idempotency. We talk about declarative versus imperative. And this is kind of fun because you might think, because I'm writing a program, that it is imperative, but really it's declarative in that I am declaring the end state of my resources. That is what I am creating, is a declaration that says, this is what I want things to look like. And if you really want to think about it in a lot of ways, any of this type of infra code or infra software, I haven't figured out how to shorten that up. It's all very complex and interesting, but at the end of the day, this is all just a test and repair loop. We're saying, I want my stuff to look like this. Does it look like that? If not, fix it so that it does. That's declarative configuration management. That's declarative infrastructure as code, test and repair, okay? But this declarative syntax, in the case of how we think about this with Pulumi, we're using a consistent object model, right? For all the resource types that come in without having to need to know all the underlying API operations that happen. So you're not coding directly against DO's API. You don't need to know, you know about the resource that matters to you, right? And exposing out those pieces that are what's interesting. And again, those of you who've maybe worked with other tooling around this, it seems like it's, we all know lots of hoops to jump through if we just want to do a conditional, if we just want to loop and iterate over things. And because if you're using a programming language like say Python, guess what? That's all just built in. This is part of programming, right? So this is bringing that full functionality of those programming languages to our infrastructure as code, right? So I'm able to, like in this example, be able to loop over public CIDRs that are CIDR blocks for these subnets, so I don't have to go and iterate over each one. And then again, this multi-provider workflows, right? So I've got my Kate stuff. I'm pulling some stuff from different clouds. I have custom resources for my own specific things. Maybe I'm bringing in PagerDuty as part of what I'm doing here. And this is giving this, again, not only is it consistent that I'm reasoning against all of these different services and underlying infrastructure that I need to work with, but I can tie them together, right? And they can interact from each other and how I'm provisioning that. I don't have a different way of spinning up for this particular service, this particular cloud. And this orchestration comes in. We're not talking about Kubernetes type of orchestration, but we don't live in one place. DigitalOcean is amazing, but your applications and services are not 100% composed of DigitalOcean services. Again, maybe you're using Datadog for some things. You probably are. New Relic, PagerDuty. Maybe you've got stuff that goes into ServiceNow. All of these pieces and parts. So again, when I talk about this is not a multi-cloud argument. This is just sort of saying, like, the reality of the world is that we aren't all in one place. And sometimes you might have some information, something through the deployments, multi-step, and you have to get some of the data from these other services. And because these are all objects and resources that expose outputs, they're all part of our program that we write. And that's where things get super duper powerful. Really, we could spend a lot of time arguing about what test-driven development means and how does that apply to like TDI and test-driven infrastructure. But we want to be testing our infrastructure code itself, not just the resources we create, right? Monitoring is just testing with a time dimension, but we're not just testing the output. We want to know, did I accomplish what I was setting out to accomplish? And because we're using an existing programming language, we have the entire testing suite that might be available to that language for applications. and being able to bake that into our CI/CD workflow. And then again, we want to be able to build and share reusable components to abstract our complexity. And so these components we build, they're going out there, we're publishing them through existing ecosystem package managers like PyPy, NPM, publishing them as Go packages. These are all things that can be made either whether we're sharing reusability because it's helpful to the community and there's other people, or even just internally so that my team creates something that can be used and just brought in as a component as an existing library. And again, this progression can be a sign of engineering maturity. There's no end state. You're never fully mature. Sorry, we always got more we can do. And a couple of the places where this comes in is, again, how are we thinking about secrets? And secrets are a piece of this. Pulumi has built-in encrypted secrets management. There's quite a bit of ways that we keep that from exporting out to the console, getting in front of eyes that maybe shouldn't have to see them. And really, this is the thing. Like, as we work through this empowers us as cloud engineers, the people who are building, deploying, and managing these services within the modern cloud. We can deliver quickly, we can deploy confidently, we can operate securely, and then help scale easily. So, thank you for today. I know this was pretty quick. I'd love to talk to you all some more. My name is Matt Stratton. You can find me on Twitter at Matt Stratton. I don't think I published these slides up, but I will shortly. All of this talk and all my other talks upcoming and previous are at speaking.mattstratton.com. And also, in addition to my podcast, Arrested DevOps, I also host an online game show called DevOps Party Games. And thanks for your time.